Hello, everyone. My name is Wenbo. I am one of the software engineers on the gRPC team. I work at Google Cloud. Together with Eryu, we prepared this talk on gRPC-Web for the KubeCon. Eryu currently is the main maintainer for the gRPC-Web project, and I created the project. I started the project quite a few years ago, back in 2018. I'd also like to thank the CNCF organizers to give us this opportunity to post this recording. Due to travel reasons, I am not able to give the talk in person at the KubeCon. So today I'm going to cover three parts. First, I would like to give you an introduction about the gRPC web, specifically, the history and also the design goals we had at the time. Then I'm going to talk about the lessons. So we launched the project uh, in, I think, in October 2018. So it's been almost 5 years. So over these 5 years, we did learn a lot, and we also have more data that we can share with you. So I'd like to share the lessons and experience we had. Then the last part, we'll talk about the roadmap, specifically to address the gaps in a few areas we heard from the users, developers. I started with this sort of broad overview of what gRPC is, and then what is special about doing something like gRPC on a web platform. So on the left side, you can see there's a diagram. This is a very high level overview of what gRPC provides. So the client will send a request over HTTP2 protocol, and then the server will generate a response. And in addition, there is also a service Protobuf-based service definition which provide the contract for the RPC, specifically the request message, the response message, and also the actual service on the server side. Now you look at the right side of the diagram. This is what really things look like when you try to do an RPC on a web client, like for example, from a browser. Now there are two things that are unique between the two diagrams at a very high level. So for a web platform, for a web client, the actual protocol, the communication is managed and controlled by the so-called web platform. Typically, we call this user agent instead of the RPC runtime. Second, almost in all the production deployment, the web client does not really talk to the server directly. There are always some kind of proxies between the client and the server. Sometimes on the client side, we refer to as forward proxy, but there's also on server side, which does load balancing, all that, which typically referred to as a reverse proxy. And there are also different types of proxies. Some provide firewall functionalities, some does gateway, which does some translation between different protocols. So, so that really make the web platform or making gRPC work from a browser very unique compared to the typical server side, client server RPC communication. So because of the uniqueness of the web platform, we have established a few design goals when we started this project. So I want to just give you an overview of sort of the history. First is we decide that we like to keep the gRPC web protocol, which is a dedicated protocol specifically designed for gRPC web clients, to match as closely as possible of the so-called core gRPC web protocol, which is based on HTTP2. The hope is that over time, the difference will become smaller and smaller, and then maybe one day, browser clients can directly talk to a server without any translation. So that's one of the motivations, but also try to keep our stack as simple as possible. Instead of we have all different divergent protocols, we try to keep the whole protocol, the core semantics of the protocols very close to each other. But on top of that, we also understand that web is different, it's unique. There are certain concepts such as cost, which is unique to the web, right? Cost is when a security model that allows a web apps talks to a different origin, which is different than where the web page is downloaded. Those are very specific to to web clients. It doesn't really apply to other type of RPC communications or environments. The second sort of design goals we had at the time is we want to make sure that the solution we created will allows a tight integration with the web ecosystems. Specifically, we're envisioning that the gRPC-Web will be used for building real web applications that interact with the gRPC-based microservices, as opposed to just providing development or debugging tools that's browser-based. In that case, you can imagine the browser actually will talk to the server directly, and you kind of have the full control of what browser versions you want to use and what environment you want to run the client and the server, which is not really the case when you look at the internet-based web applications. The second design goal at the time we made it is that instead of build the gRPC-Web support in every language for its gRPC implementations, we rely on Envoy to translate the gRPC-Web protocol to gRPC. In some cases, the same functionality can be provided by language-specific native web frameworks. I'll talk about this a little bit more at a later slide. Then the other design goals we had is that really try to keep this whole solution as simple as possible. Specifically, we made a decision that we will only support server streaming. There are two main reasons. One is that any kind of other streaming modes will require support of protocol like WebSockets, which will significantly increase the complexity, especially the code size of the libraries. The second is, we look at all the different use cases for streaming. Really, the majority of the streaming use cases for a web client when communicating against the services over the internet is really server streaming. And also server streaming is very simple, very close to the core RPC semantics. It's largely stateless on the server side. When all the other kind of streaming, like request streaming, bidirectional streaming, or line-lived streaming, which require a lot more work beyond what just RPC provides, which means that even we create a solution that that support those kind of streaming modes, you as an application developer still need to understand and how to deal with this reliability and scalability, and those things are very unique to the nature of the streaming being stateful solutions. Then the second part is that we want this to work everywhere. What that means is the gRPC web client should work on very old browsers like IE at the time. It needs to work from different networking environment, which means that different HTTP versions, or in some cases firewalls may block certain versions, and also work from those so-called cross-platform web clients, for example, Reactive Native, which is also used on mobile clients, but otherwise we consider this as a web platform. So we wanted the solution to be simple for applications so that they don't have to worry about when this solution will work or will not work, right? And that's very important goal for us. So this is all the sort of the background I want to cover today. And then the next I'll talk about what we learned from the past 4 or 5 years after we launched this project. So first, we at the time made a decision that this solution has to work for both Google's own internal applications and also for external applications, which mean applications you guys build using GitHub open source releases. And what we noticed that is this is a very significant benefit for a lot of our users, because now they trust that this solution also works for Google, and they're more confident to use it in their production as part of their production solution. If you look at the diagram, the overall the gRPC, we don't have a lot of signals to actually measure the adoption of gRPC-Web. So this is just one of the signals which is very easy to get is the number of stars. But if you look at that, the red one is Java, the blue one is for web, and then the yellow one is for Node. And overall, the adoption of the gRPC-Web has been pretty steady and keep growing. However, such an approach, it does have its own challenges for us. Specifically, now we have to make trade-offs between taking new features, exposing new APIs versus the code size increases. Now, for internal Google's own applications, you can imagine, for example, like chat, Gmail, or search, code size is very important. Usually, it's most critical performance metrics. When for external developers, you have the a very wide spectrum of users, right? Some may not care about code size as much. Then the other part of the overhead is really keep the code repository in sync, and any kind of bidirectional code sync between an external repository and an internal repository, like the one used by Google, the Google's own internal applications. It's a very complicated, just process-wise, how to deal with, rollback, how to detect issues, and how to do merge and do patching, managing releases, and that does provide, it does present a lot of challenges for us, and which also, as a result, costs us really very careful to release any new features. We want to make sure that this is as stable as possible. It works very reliably for both Google's own applications and external web applications. The second lessons we learned is that gRPC Web rely on two key Google-only technologies, and that does cause a lot of issues for our users, which we didn't quite expect at the beginning. So the first one is the Google Closure Library and the compiler, and this turns out to be a very Google-only technology today. As any like web framework, it's very opinionated in terms of the style, conventions, and trade-offs, and this doesn't always work for other developers. So for that, we don't really, we will stick with this Google Closure Library and compiler because we wanted this thing to also work for Google applications. But we try to hide this as more or less as an internal implementation detail. Hopefully that we can reduce the the user friction caused by the dependency on Google closures. Now the second one is the issue there is more significant, which is the Protobuf itself. So gRPC Web relies and exposes the Google Protobuf JavaScripts. Its open source version, unfortunately, does not provide the best user experience, neither the performance. So we don't really have immediate solution. I'll talk about this briefly when we talk about the roadmap. But overall, this is sort of the lessons we learned. When you create a solution that you want used by both, Google applications, but also open source external applications, now you have these kind of trade-offs, and it's one of those cases one size doesn't really fit all. Then the last part about the lessons is, when we look at the design goals we made at the time, looking back, we feel like we made some reasonable decisions, specifically on the server side. As Envoy become more and more popular and especially easier to deploy in the so-called cloud native or Kubernetes environment, our original concern that requiring a proxy will cause all the deployment overhead doesn't seem to be a real user experience concern. What we heard from users is, deploying Envoy is very easy, and it doesn't really cause any problems for most of the users. The second one is the in-process sort of translation between gRPC Web and the RPC handlers. At the time, we basically made the decision not to implement gRPC Web directly in different languages. However, for languages that they implement gRPC on top of the web platform or web frameworks. In that case, gRPC Web and the gRPC become two parallel stack on top of the language native web frameworks. In that case, proxy become unnecessary. And that has been the case for .NET, Swift, and Dart. And that kind of matches our vision at the time. For these three languages, gRPC-Web and gRPC kind of implemented seamlessly against the web framework, and they will invoke the RPC handler also seamlessly. In that case, Envoy is not needed. The other goal we had is basically we want to just keep gRPC Web as a web-only solution. This is not a general fallback for gRPC. We don't want people to use gRPC Web because gRPC, for example, does not work on embedded system or in some environment, or people don't like how we implemented the APIs or anything like that. And for that, we envisioned that the ecosystem will pick up and create some solution to sort of bridge the gap, and that has been happening. There's a popular gateway like the gRPC gateway, which provided a very good solution that you can write the REST kinds and that will interact with the gRPC server transparently. So overall, for us, is we try to make sure that the gRPC Web, as an official solution, focus on the core values, and we make very diligent trade-off between complexity, code size, and features. One example is in Google. Every 1 kilobyte of code size increase will generate alert. We have to justify why we're doing that. What is the value provided by this actual 1 kilobytes of code. So this tells you, we really try very hard to make the trade-off. Next, I'm going to just briefly talk about the roadmaps. One of the most requested features you can imagine is the streaming support. So what happens is at this point, we decide that gRPC Web will only be providing server streaming support over HTTP. The reason we made this decision is that we worked with the Chrome team and did a so-called origin trial. So this is like official, this is like some kind of experiments we can enable from Chrome against live traffic. In this case, any Gmail traffic, which will use this to sort of do the experiments. Unfortunately, the experiment failed to conclude that it is safe to enable client streaming over HTTP 1.1 from browsers, from Chrome. What that means is that if we support like a request streaming using the fetch streaming APIs as provided by web platforms, when the underlying protocol is HTTP 1.1, the RPC library will have to do some kind of fallback to disable streaming, and this will greatly increase overhead. And also HTTP 2 only works with HTTPS. So if we want to do plain text to HTTP, then there's no HTTP 2 as well. So because of all these reasons, we decided not to pursue request streaming support with the fetch streams API. We plan to support web transport over QUIC specifically to support full duplex streaming at some point. This will also cover and enable request streaming. Web transport, because it's QUIC-based, it does provide latency improvements, and also web transport also provides some default fallback. So we believe that there's enough value to justify to support this extra transport in addition to HTTP. So we're looking into that. We'll keep you updated as we make more progresses. So, and then the next one is the Protobuf. So we are working with our internal Protobuf team as well as external Protobuf JavaScript projects, try to figure out some kind of roadmap and also migration paths, depending on how we decided to support, to integrate Protobuf, JavaScript, and the gRPC Web. In addition to the Protobuf JavaScript messages, we also think it may be beneficial to support JSON messages, especially if we don't have a clear roadmap or migration path on Protobuf JavaScript in a short time frame, which allows us to provide the best user experience. In that case, we may decide to decouple gRPC Web and the Protobuf messages and allow applications to actually just using the standard JSON messages, which is also part of the Protobuf spec. The second things related to Protobuf is we try to make more alignment between Node and the web. A little bit of history about the gRPC JavaScript, the so-called gRPC JS, which is designed for Node. Google internally does not use Node as a server-side language. So as a result, gRPC Node actually use a different Protobuf library, and also the APIs are different. So we like to get into a position that the gRPC Node users and gRPC Web users, they can have the same kind of Protobuf experience if they choose to. So what that means is we may try to provide different options for gRPC Web. So gRPC Web users may decide to have use its own customer version of Protobuf instead of we mandate a particular Protobuf JavaScript library or implementation. So we're looking into that, and together with also the gRPC Node team. Now, gRPC Web and gRPC Node at the API surfaces was always designed to be aligned. For example, the gRPC Web, the Streams API actually copy the exact Node Streams API spec instead of exposing the so-called WordWag streams, which are which are defined by the web platform. Lastly, I want to just touch base quickly about the ecosystems. There are two things. One is on the server side. As gRPC Web become more stable and mature, users start looking into other functionalities, things like different security features or auth, those things. We don't really have a standard solution at this point. We like to release with gRPC Web, mostly because our internal versions are not quite suitable for external users or vice versa. So what we think we can do is to improve the overall ecosystem, is to document some specs or publish some guidelines so that features implemented in Envoy versus features implemented in, let's say, .NET, Dot, they have some kind of consistency, and the clients can also interact with those different web frameworks in a more portable ways. So that's something we are looking into that. Then the second part is the so-called client-side web frameworks. Over the years, we've been working with project owners from Flutter, Angular, also Reactive Native, make sure that gRPC Web will work from those frameworks more seamlessly. I believe today you can use gRPC Web from all those frameworks, but we're looking to make sure that the overall experience is more aligned, more seamlessly for developers. The other thing is more try to make sure that the gRPC implementation itself is more unified. One area we have been looking at is the gRPC Web on Dot. Today, the gRPC Web client on Dot is implemented in Dot. Our goal is to have the Dot client wrap the JavaScript client, which we designed and implemented for the standard web clients. The reason is that the gRPC Web protocol and transport and the feature sets will evolve. For example, when we started to support the web transport, we like the Dart clients automatically get those features as opposed to try to re-implement everything. This will also make things easier. For example, make patching and releases easier. So that's something we are also looking into that. So this concludes the main top part of the roadmap discussions I'd like to share with you. If you want to reach us, just go to the github.com/grpc/grpcweb and post your feedback questions on the web on the GitHub repository directory. We will try to get back to you as soon as possible. So that's all I have today. Thank you so much.